So next up, I would like to introduce Kelsey Prena. Kelsey is a doctoral candidate in communication science with a minor in neuroscience at the Media School at Indiana University. She is interested in the neurological changes that occur during video gaming and how these changes influence learning and memory. The goal of her research is to use these changes to facilitate learning and memory in children with special needs. Mechanisms that she is currently working to understand relate to neurological deficits in people with Down syndrome. While at Michigan State University, Kelsey received her BA in 2012 and MA in 2014 in communication. Her MA thesis focused on identifying video game trends in children with Down syndrome. Kelsey is an active member of the Institute for Communication Research and the Cognitive Neuroimaging Lab at Indiana University. So Kelsey, welcome.
Hi. So I actually had the honor of working with a couple of families with children with Down syndrome before I really dove into the research that I was working on and that I'm still working on today. One of the families is actually here in the audience today, which is very exciting. And so I have built my research and the mechanism that I'm working on around Down syndrome, different parts of Down syndrome, but particularly the hippocampus, which I'll talk about in the next slide a little bit. I know Dr. Head talked about the hippocampus, so I will build on that. But arguably, I am looking at the potential for video games for learning and memory. Before I get into my research, which I will only talk about super briefly, I do have a little bit of theory, as any good grad student would, right? A little bit of theory to go over before I talk about my research. First, the hippocampus, like I said, and that Dr. Head also talked about, is that the hippocampus is in charge of many aspects of learning and memory, particularly in declarative memory. This is remembering events, facts, associations, and experiences. Anytime that you're really remembering when or where an event took place, this is the hippocampus did its job. And the hippocampus is also involved in spatial memory. This is particularly where something is located, some mental representations of space and shapes as well. Dopamine is a neurotransmitter that facilitates hippocampal processing in the brain. I will talk quite a bit about dopamine in this presentation, and it's just important to keep in mind that dopamine facilitates hippocampal processing. Gaba, on the other hand, inhibits hippocampal processing. Gaba tends to be an inhibitor, a neural inhibitor, and particularly in the hippocampus, we see that Gaba is an inhibitor of hippocampal processing. So now let's talk briefly about the Down syndrome hippocampus. In Down syndrome, a commonly supported theory currently is that Gaba is overproduced. This makes memory very difficult, especially at the neuronal level. Inducing memory formation is very difficult, and when Gaba is suppressed, memory is facilitated in these models. I know Dr. Roper talked quite a bit about trisomy mice, and there are currently a couple of studies out showing that when we suppress Gaba in these mice, we see enhanced or improved memory formation during the mice explorations and cognitive tasks. And then finally, what you guys are probably most interested here is that video games may induce the reward cascade, a mechanism thought to increase dopamine. So people who play video games and experience the reward cascade tend to show general trends towards dopaminergic influx, as well as a suppression of GABA. This is common of the reward cascade, but I say that it may induce the reward cascade, particularly because this part hasn't been studied, and this part is what I focus most of my research on currently, is trying to establish that video games do induce the reward cascade. And in doing so, we hope to see an increase in dopamine and a decrease in GABA, which, if you refer back to a couple slides ago, I mentioned that dopamine facilitates memory formation where GABA inhibits memory formation. GABA is still important. It's not a big, bad neurotransmitter, right? GABA preserves the connections that we've already made. So we need GABA as much as we need dopamine. But in memory formation, dopamine tends to facilitate, dopamine facilitates memory. And this is the theory that I base most of my current research on. It's called the penumbra hypothesis. And this argues that when dopamine is heightened, memory is facilitated until dopamine returns to baseline. And so what we see is that even after the reward cascade has been induced, the person or the mouse has achieved the reward that they were striving to achieve, we still see dopamine heightened for some period of time after the retrieval of the reward, and their memory is still heightened immediately following that retrieval. And finally, my concept map. Again, this is a result of being a graduate student. I argue that video games increase reward in the hippocampus, or the reward cascade in the hippocampus, which decreases dopamine or decreases GABA, increases dopamine, and then facilitates learning and memory. And now just briefly, my current research that I've been working on. So the research question that I have focused on for the past couple years now is, can playing video games with clear reward influence short-term declarative memory? What we did was that we had participants in 4 different gaming conditions, 2 with very clear rewards. They had goals, they earned coins, they leveled up. So very clear reward conditions. And then we also used there were no rewards in these games. So we used the 2 extreme ends of the spectrum here. We had participants who were in the no reward conditions basically just explored. There wasn't anything to find in these games. They may have been coloring a picture where they just pick a color and drop it into a space. It was very uneventful, and I got a lot of complaints from my students. The participants who had to play those games were not particularly happy with me when I pulled them out of their gameplay. So essentially, we had very clear rewards and no rewards. And in using the penumbra hypothesis, right, those in the very clear rewards where dopamine is increased, right, their memory should be heightened even once they're done playing games, after they've achieved the rewards that they're playing. And so those in the rewards condition will remember more words exposed after gaming than those in rewards absent conditions. And this is what we were particularly excited about. So just a little bit of data here. I don't know if you can read this. I might step off and explain it a little bit. So what we see here is that we have no reward conditions represented by 0 on the x-axis and reward present conditions represented by 1 on the x-axis. And then we have the number of words they were asked to remember. So negative is the amount of words that they forgot. What they did was we asked them to remember words at the very beginning. They played the video game, asked to remember the words, took a 30-minute break, brought them back in, and asked them to recall the words that we had run through with them at the beginning. So what we see here is that there is a significant interaction between no rewards and rewards present conditions, where those in the rewards absent conditions did significantly poorer on the task than those in the reward present condition. We also see a difference here between gamers and non-gamers. Gamers are represented by the 1 over here in the key, and non-gamers are represented by 0, or the dashed line. We see that gamers did significantly better. They remember significantly more words than non-gamers. So my hypothesis was supported. is very exciting. So what we see here is that there are potentially long-term effects of gaming on hippocampal performance and on declarative memory, as well as short-term effects just influenced by 40 minutes of gameplay in the reward condition. I'm also currently running a study that looks at Gaba in the hippocampus. I would love to also look at dopamine, but particularly in MRI data, dopamine is very difficult to pull out. So we've been looking at Gaba using MRI spectroscopy instead. This does come along with some technical issues, but my overarching question here is, does Gaba decrease when playing reward present conditions? To refer back to the reward cascade, we should see a decrease in Gaba in the hippocampus during gameplay with reward conditions. But also, the reward cascade includes the ACC, and we really struggled to pull out Gaba data from the hippocampus. It is a hard region to kind of define in the MRI scanner. And so we tried a little bit briefly with the ACC. The ACC is kind of, during the reward cascade, that's what gets the Gaba. That reduces the Gaba in the hippocampus. So we should see an increase in the ACC. We should see an increase in Gaba in the ACC. So this is what the results look like here. I know the results are very clear, right? This is just one of the scans. There were 5 over the course of gameplay. For those who can't read this graph, I also provided numbers. Oops. You can see that 8.5, 81, 36, 83, and 64, which are references to the concentrations of Gaba. We can see a general trend of increase during gameplay with some fluctuation, which is what we had hoped to see. We hoped to see a general trend in Gaba increasing in the ACC. And currently, I'm very excited about the research that I will begin conducting for my very small paper called a dissertation. And so I have several questions going along with that. How do different video game mechanics, including reward and spatial navigation, influence hippocampal activation? And Gaba concentrations, do different activation patterns influence short-term declarative memory and associative memory, as well as long-term memory consolidation? And then this is really where Down syndrome comes in. How does this mechanism, so increasing dopamine and decreasing Gaba in the hippocampus during video gameplay, how is this mechanism preserved, and how does it differ in those with Down syndrome? And what kinds of video game design decisions facilitate gameplay in those with Down syndrome, and do those influence the effects of games on memory? Don't race out and go buy video games. Dr. Roper said not all EG/CG is made the same. Same thing with video games. Not all video games are made the same. But I do think that there is a major potential here for a fun kind of intervention that you can have where you can play video games with your children and have positive effects that go along with that gameplay. And that's all I have, I think. Thank you.